Law of cosines. The law of cosines appears in three formats based on which side and or angle that you are looking for. The first version is little a, which is across from angle A squared, is equal to little b squared plus little c squared minus 2 times b times c times the cosine of a. Notice that the first and the last letters in the equation correspond to one another, meaning that the side, lowercase a, is directly across from angle A. And the same holds true for the other formats. Notice we have little b squared is equal to a squared plus c squared minus 2ac times the cosine of angle B. And again, angle B and lowercase b are on opposite sides of the triangle. And the last version of the law of cosines is little c squared is equal to little a squared plus little b squared minus 2 times little a times little b times the cosine of c. And again, c, the side, is directly across from angle C that is given in our equation. These laws are mainly used when we are given the side, an angle, and a side, or three sides in a triangle. In our example with a side-side-side triangle, like all the sides are given to you, any of the angles can be found first. We're going to start with angle A. So the side across from angle A is 7, so we have 7 squared is equal to 8 squared plus 6 squared minus 2 times 8 times 6 times the cosine of A. And again, notice that the cosine of A is far on the end of the equation, and on the opposite side of the equation is that side. Now let's finish solving this equation for the measure of angle A. We'll begin by evaluating our exponents and finding the product. So we'll have 49 is equal to 64 plus 36 minus 96 times the cosine of A. And then we can combine our like terms. And our like terms are 64 and positive 36. When we add those together, we'll end up getting 100. And then we still have to keep minus 96 times the cosine of A as a separate term. And now we need to move the 100 to the other side by subtracting it. And when we do so, we will get negative 51 on the left, and then that's equal to negative 96 times the cosine of A. If we divide both sides by negative 96, we will have that positive 51 over 96 is equal to the cosine of A. And now we're going to take the inverse cosine of both sides in order to determine the measure of angle A. And when we take the inverse cosine of 51 divided by 96, we end up getting 57 and 9/10 degrees for the measure of angle A. And since the cosine value that's given is between 0 and 180 degrees, we don't have to consider or check for other cases. Now there's another note about the work that was shown here. Remember how we combined 64 and 36 together to get 100? Some people might be tempted to do 100 and then subtract 96 and get 4 cosine of A is equal to 49. We can't do that because the negative 96 is with an unknown. You could think of it as 49 is equal to 64 plus 36 minus 96x. These two are like terms and we get 100. But minus 96x, we can't combine that with 100. So that's another way to look at how we solved for and found the measure of angle A. When using the law of cosines in a side-angle-side triangle, where a side, an angle, and a side are given, the side opposite the included angle is found first. Because we have the measure of angle B as 100 and the side across from it is little b. So that's our unknown that we have. We already have A, which is 4, and we have lowercase c, which is equal to 7. So we can set it up as b squared is equal to 4 squared plus 7 squared minus 2 times 4 times 7 times the cosine of 100 degrees. Notice that the cosine of 100 degrees is on the far end of the equation, and on the opposite side of the equation is that side opposite of angle B, or lowercase b, quantity squared. And now let's continue to solve this equation for lowercase b. So let's start by evaluating the exponents and the multiplication that we have here. So we have b squared is equal to 16 plus 49 minus 56. And then if we execute the cosine of 100 in our calculator, making sure that it's in degree mode, we will get negative 1,736 10,000ths. And then if we multiply, or first let's add these two together and we get 65. And then when we multiply negative 56 and our negative decimal together, we get a positive value of 9 and 7,216 10,000ths. And then if we combine those values together, we'll end up getting that b squared is equal to 74 and 7,216 10,000ths. Now, we're not done yet. This is what b squared is. So in order to figure out what b is, we have to square root both sides. And when we do that, we'll end up getting that our b value is approximately equal to 8 and 644 thousandths. And then at this point, once we have found this b value, we can either use law of sines or law of cosines to find the other missing pieces of information in our triangle. But make sure that law of cosines, it has many operations as we've seen, and the law of sines, while shorter, will have to be checked for multiple solutions. Because remember, sometimes the sign could be positive in quadrants 1 and 2. So we have to take the sides into consideration when determining the appropriate value for our angles. Now let's try solving an application problem using the law of cosines. Joe went camping. Sitting at his campsite, he noticed it was 3 miles to one end of the lake and 4 miles to the other end. He determined that the angle between these two lines of sight is 105 degrees. How far is it across the lake? Well, we can see here that we have a side given to us, an angle, and another side given to us. So we're going to use the law of cosines. And because we have the angle of 105 degrees given to us, we're going to have the unknown value x squared on one side and the cosine of 105 degrees at the other end of our equation. And then we fill in the other missing pieces. So we have 3 squared plus 4 squared minus 2 times 3 times 4 times the cosine of 105. And then if we evaluate these, we'll have 9 and 16 minus 24 times the cosine of 105 degrees. And then we can combine the 9 and 16 together to get 25 minus 24 times the cosine of 105 degrees. And that's still what x squared is equal to. If we solve this for x, we're going to square root both sides. So therefore, x will equal the square root of 25 minus 24 times the cosine of 105 degrees. So if we switch over to our calculator and have it evaluate the square root of 25 minus 24 times the cosine of 105 degrees, we end up getting about 5 and 59/100ths. So x is approximately equal to 5 and 59/100ths miles. And here we have the solution to this problem shown, and it does match the solution that we calculated of 5 and 59/100ths miles.